Section 3-6. We're going to construct parallel lines today, right? We're going to do two things. We'll construct parallel. We'll construct perpendicular. You've already done perpendicular constructions on your project, right? Duh. You've already done that, so it should be kind of a review. It's a little different, but it's not totally different. So, in the grand scheme of things, I was like, hey, let's just put the instructions on there. Student will read instructions. Student will do instructions. Student will be done. No, not at all. Woo! All right, so there it is. In case you want to read it, that's math diarrhea as far as I'm concerned.
I can't read.
Allow Baker to add a layer. So I want to construct line DJ so that it is parallel to line BC. Cool? Here's your first step. Follow along. You're going to take your straight edge and you're going to draw line DB. Nailed it. So, when you draw line DB, it also creates angle DBC. See it?
Yes.
Is anybody confused on the first step?
No.
I'm asking.
Nope.
Everyone's good. All right. So let me bust out my compass real quick. Digitally. Math tools. Compass. So the next step, you're going to put your pivot point on D. Well, green. Step 1. Pivot point goes right here. Now watch. Remember, I have to do like the watchmaker do it before you do it. Otherwise, you're going to get lost because you can't multitask very well. So we're going to make sure our compass will intersect the green line above D. So when you swing an arc, you need to swing an arc that hits the green line up top. And I would encourage just to go a little bit below D. So that's step 1. And you're going to hate me because you guys aren't paying attention. Once you do that arc, do not change the radius of your compass. Go to B and draw the same arc. So you're doing double arcs, one at D, one at B, and they must be the same arc. Okay, yeah. If your compasses suck, go get a new one, or I have the tools to reconstruct them. So many
Oh, you're cool. I didn't get it. I didn't get it at all.
It's a trap.
Literally all of they do.
I cannot do this. Nice.
You're being recorded.
I am?
Yes.
Nice.
Alright, so at this point, we put our pivot point on D and swung an arc. Put our pivot point on B and swung the exact same arc.
Little bugger. Trust me.
Okay, so step 2 and the final step. Oh, hey, we're almost done. It's a 2-step construction.
Let's go.
That's what I said. Math diarrhea. Baker's got the gold here. So what we're going to do is we're going to grab our compass and move it to the intersection down here and open our compass so that it is the measurement of the angle. You may not see that. No, I did it wrong. It should be the other way. It should be the pivot point up here and the pencil point down here. So now I know my my angle is this much open. Without changing that radius, I'm going to move up here to this intersection, and I'm going to swing an arc through. And you're done.
Wait.
Oh, hold on. You haven't seen the magic happen yet.
Oof.
When you draw a line from this point through that intersection, those lines are noted as parallel. Yay!
And then we go here.
Now, y'all are freaking out, right?
C.
I messed up.
Here's what happened. You guys just duplicated an angle.
Really?
That's all you did was duplicate an angle.
Because they're corresponding.
Because corresponding angles are congruent,
No way.
lines are parallel. Oh my God, he just made everything connect. All right, ready? I want you guys to watch the whole thing. Don't put your compass down and watch the whole thing.
But I did it.
So, step one. Watch with your eyeballs, please. Step one. Draw a line that connects B and D. Cool? This is known as an angle.
Is it?
Alright? So what I'm going to do, pivot point goes to D, and I'm going to swing an arc. It doesn't matter how big your arc is. Once I establish that radius, I am not allowed to change it. Arc. Without changing anything, move to the other location, arc. At this point, I can move my compass and establish a new radius. I'm going to put my pivot point here and measure how open this angle is. Pivot point, pencil point. This angle is this big. Arc to verify. Yes. Move it up here to this intersection. Arc to verify. Yes. When I connect this and this, they're parallel lines. And I did a bad job because I didn't get the point exactly where it was supposed to be. These angles right here and right here are congruent corresponding angles, which generates parallel lines. Cool, right? Do you got it?
Time out. I have to redo it because I did it on the wrong one.
But wait. But wait, Blake. Guess what?
What?
There's more.
Flip the page.
Yeah, see, I did it on that one.
Okay, we're actually going to skip
Great job.
to this, the exercises portion, because I want you guys to just practice parallel. So, please, please, please. It says construct a line parallel to M that goes through point Y. This is tough for me, right? Why is this going to be infinitely more complicated than the first example?
Because we're.
There are no instructions listed. We just talked about the instructions were garbage, right?
Yeah.
Look at this picture.
Oh, wait, there's not another point.
There is no longer points on that line.
That makes my kid.
So, as a student, you must put your own point on the line, right? Doesn't matter where your point goes.
No.
No, it doesn't. Will it always generate parallel lines?
Yes.
Yes. Watch Baker do it. Watch. Ohos only. Then you can use your hands. I'm going to pick that point right there. I'm going to call this point H because it makes me happy.
Does it? Alright.
The first step in this construction, draw a line that connects the happy point to the Y point. Use your straight edge, go from here to here. Have I completed the first step?
Yes.
I have 2 more steps until I'm finished. Step number 2. Put your pivot point on Y. You need to draw an arc that goes below Y and above and make sure it connects, right? Without changing the radius, without changing anything here. Move down and draw the same arc. The last and final step, I'm going to measure how open this angle is. It is that open. Without adjusting that radius, I will go to this location right here. Wait for it. Wait for it. And I will swing the same arc. When I connect this point and that point, does it appear that the red line and the black line are parallel? Congratulations, mathematics is happy. Student tries.
Student tries.
By yourself?
And guess what? You have 3 different lines to try on. So if you screw up, put a big X through it and said, nope, and go to a different one and try it again.
I'm gonna cry myself.
Can you do it with an
Sleep.
obtuse angle too?
Ow.
Okay. Because that's where you are you gonna have to deal with those two? 'Cause the-
Yes, yes. Can you? I mean, your faces tell a million stories. Can you do it? I'm about to do it the right way. Because it's a right angle. Oh my God, he's so
I'm
funny.
going to throw something at you.
Did it work?
This paper is
Snailed it.
Oh.
Wait, then how did you
Magic.
Never mind.
Time out. My line is not long enough. Yeah. I hate when that happens. My line is just not long.
Alright. Hey, wait, I got
I did something wrong. It's fine. Hey, it happened.
Well, cause like, okay, yeah.
So here's the issue, right? We're going back to these crummy little compasses that don't stay when they're told to stay, right? It's like that bad dog.
Yeah.
You cannot force it to stay there. If you're using 2 hands to construct this, you're already putting yourself in a bad spot. Right? Remember, just like MJ is demonstrating, you hold the pivot point here. And you can turn your paper and you can rotate your fingers to swoop it. Guys, it's just practice. You guys have to get good at practicing. Why? Why are we spending so much time doing this?
Practice makes perfect.
Because it's on your test.
Oh. He's mad.
I'm not mad, I'm excited, right? You guys have to know why I'm expecting you to do this. So look, let me show you on the right one. Get it? Is it the right angle? I'm gonna drive that pun into the ground.
Do you want us to wait?
No, this is you guys just watching, right? If you got it and you're trying, then keep trying. If you don't got it and you need help, then watch. I've done step 1. I drew a line that connected point Y to this line. That's always step 1. Connect the dot to the line. Then I take my compass and I go to that dot. Remember, you swing an arc above the point without changing anything. Go to the line and swing the same arc. Right now, I have just swung 2 arcs. I swung 1 arc at this location, and I swung, at this location, and I swung 1 arc at that location. We'll call that the vertex of the angle. The next thing I need to do is measure how big that angle is open. This angle is that big. You see that? That's easy for me to do because I can take my hand away and my compass doesn't move. So I need to go force this angle to be that big. And then I connect the dots from here to here. Crazy, right? So look, I'm going to abandon this problem for a second. Just for a second. And give you time to practice. Because you need it. Let's go back to this one. A perpendicular line.
I did it.
I need to draw a line that is perpendicular to BC, and it must go between or through D. Does that scare you? So watch, Mita, with your eyeballs, don't do anything else. Step 1, right here. Step 1. Pivot point goes there. You're going to rotate your compass so that your pencil is below the line. You're watching. You're not doing anything. Watch, right? Does everybody see what step 1 looks like? So for step 1, you're going to swing an arc that goes across both sides of the line. Does it matter about B and C? No, nobody cares about B and C. Okay? The intention of this problem is to create 2 points. Right? I created this intersection and this intersection. If you get lucky, you could stretch your compass out to C, and you could use those 2 points I created for you. See that? Once I establish these 2 points, I put my compass here, and just like your project, you're going to swing an arc up, move to the other location, you're going to swing an arc. When you connect, this intersection through point D, it creates a perpendicular line. Now, is that all the way what you're supposed to do? No. I'll show you one more time. I'm gonna get rid of all the instructions. Step 1, go to D. Y'all can follow along. Ready? Put your pivot point on D. I want you to stretch your compass out to where it meets C. And you're going to swing an arc through B and C. Okay? So this creates your 2 working points. Okay? Now you have one more step and you're done. One more step.
The little swingy things.
You're going to put your compass on B, and you're going to swing an arc up. It doesn't matter what the radius is. Without changing your radius, move to the other working point.
Oh.
Wow.
So when you connect the intersection of your arcs, just like your project, it creates a perpendicular line.
Bang.
Just like your project, right? We did this on our project numerous times, infinitely many times. Y'all should be comfortable with this construction. The only thing is now you have a working point to start with. Yes, Josh. You nailed it right at the end.
It's a little shaky.
It's alright, it's okay. So we get back to the practice point. It says construct a line perpendicular to end. Do you have points that you can work from?
No.
No, you have to create those points for yourself. So I'm going to use example number 4 first.
Wait, do you really need to create points then?
Yes, you do. You have to have a point here and a point here to work from.
Well, yeah, I was
Just like you did on your project, but you guys started in the middle and you swung an arc on either side. Once you establish those 2 points, you go to intersection 1, swing an arc up and down, go to intersection 2, swing the same arc, and it creates a line that's perpendicular. That was a terrible drawing.
Whoa.
I looked at my monkey got a pencil and just started doing circles.
No, because all I care about is the red line is perpendicular to the black line. That's all I care about. So let me wrap all this up in a bow for you guys.
So we just do it all.
Yeah, that'd be your practice portion. You think homework's gonna help you?
Yes.
No.
I don't think so either. Honestly, I don't, right? I'm gonna live that true life. So on the back of your paper, I'm gonna give you one question. One question. And hopefully we have time to do that in class today. Here's your one question homework. Ready?
How did
Write a 3-page essay on Mr. Baker.
Draw a rectangle. I'm sorry, that is poor instructions. Construct a rectangle.
I got this.
Because it says construct, you must use a compass and a straight edge. Does anybody have any idea how to start that?
Just draw a straight line.
So, step one. Whoop! Nailed it. That is one of 3 sides complete. Why are we doing a rectangle? Because it's on your test.
And it's 2 sets of parallel.
Huh? That is one of 4 sides. I have 3 sides remaining.
There we go.
Did I make a verbal mistake? We can always check it later on YouTube, right? Okay, step 1. I drew a line that is one of the 4 sides that is completed. I drew a line segment. Thank you, Josh. What else do I need to do to make a rectangle?
Put a point
Okay, where?
on the line.
On the line? What else? What is a rectangle comprised of?
2 pairs of parallel lines. Or 2 sets of parallel lines.
2 sets of parallel lines and 4 right angles.
Yeah.
So I need to construct a line that is perpendicular to this one. Because I put a point there, it's just like your project, right? I need to construct a 90-degree angle. So I'm going to keep it tiny.
Yeah.
Point there. Point there, just like your project. Then I'm going to use those 2 working points. Now I have half of my rectangle done, don't I? Yes, ma'am. These ones, I put my compass right here at the middle, and I just drew 2 arcs. I did this arc and this arc right there in the middle. Does that make sense? So here, look. Because my rectangle has 4 sides, and I have to have 4 right angles, I need another right angle over here. So I'm going to do the same thing. I put a random point. Let's call it this point right here. Put my compass. I'm going to draw a mark. I'm going to rotate it around. And I'm going to draw a mark. That's how I get these 2 little points. Those are my working points now. I'm going to move my compass over here. I'm going to extend it a little bit. And I'm going to swing an arc up and down, like on your project. Move to this side and draw intersecting arcs. So when I draw my new line
Well, wait.
from here through that point to that intersection, now I have 1, 2 right angles. Does that make sense? So right now I have what is known as an open box. I need to close my box. But something very specific needs to
Parallel
happen.
line.
The top line has to be parallel to the bottom lines.
that. Oh, you gotta draw two swoopy things.
So I'm gonna change colors so you can see what's happening. Where do I want the top of my box to be?
At the top.
How about right here?
Yeah.
That's cool, right? So at this point, I'm gonna use this intersection down here and this intersection right here. Is this dot connected to the bottom? Yes.
Maybe.
So go to my blue dot and I swing an arc that crosses my red line without changing it. Go down to this blue line, swing an arc. Then just like my parallel constructions, measure how open this angle is. It is that open. Move up here to this intersection. Mark to verify. When I connect from this point to this intersection all the way to the other side, it is a perfect rectangle. The crowd goes wild. Everyone's cheering ecstatically. It is perfect, just like Baker.
Oh my gosh, can you not turn?
So it is an abounding number of constructions, right? You have to do like 4 different constructions just to generate one figure. So what I care about is that you guys got some sort of just inklings of what's going on, right? And you can either laugh or celebrate about what constructions you have. At this point, I'm gonna stop the learning, right, for Baker on the mic, and then I'm gonna let you guys practice. I'm gonna start floating around helping you guys. So you have constructions in your notebooks or in your notes that you can practice on, or you can attempt to draw your own rectangle somewhere else. Okay?